Hello friends, I welcome you in lecture number 21 on higher order ordinary differential equations. In this lecture we will discuss some more examples explaining that how to select proper particular integral for the method of undetermined coefficients. So we will not solve all the problems, we will just explain or understand that how to select proper particular integral for the given non-homogeneous equation. So we start with first equation, y double dash minus 9y equal to x cube plus e raised to 2x minus sin 3x. So first we write down the corresponding homogeneous differential equation, which is y double dash minus 9y equal to 0, and auxiliary equation for this homogeneous equation is lambda square minus 9 equal to 0. This will give us lambda square equal to 9, that is lambda equal to plus or minus 3. So therefore complementary function is c1 e raised to 3x plus c2 e raised to minus 3x. Now here right hand side is rx equal to x cube plus e raised to 2x minus sin 3x. So it is linear combination of three functions, x cube e raised to 2x and sin 3x. So these functions are in the addition and subtraction. So first we have to write down the families corresponding to each function, and then we have to take union of corresponding family of derivatives. So family corresponding to x cube is 1x x square x cube. Family corresponding to e raised to 2x is e raised to 2x only, and the family of derivatives corresponding to sin 3x is sin 3x cos 3x. So now we have to check for each family whether any member is present in the complementary function or not. So if we check for this 1x x square x cube, then no member of this family is present in the complementary function. Similarly, e raised to 2x is also not present in complementary function, and no member of this family is present in complementary function. So now we take union of these three families. So union means we have to write down members which are in all the sets: e raised to 2x, sin 3x, cos 3x, and we consider particular solution as linear combination of these members. So there are 4, 5, 6 and 7 members. So we can consider a into 1 plus b into x plus c into x square plus d into x cube, e into e raised to 2x plus f into sin 3x and g into cos 3x. So this is the proper choice for particular integral for given non-homogeneous equation. Now we know how to find out these undetermined coefficients a, b, c, d up to g. For that you have to substitute value of yp in given equation, and as we have explained in earlier lectures, you can find out the undetermined coefficients using yp in this equation. Because yp is solution of this equation, we can substitute y equal to yp in this equation, and after substituting values of yp double dash and yp and then comparing coefficients, we will be able to find out all these undetermined coefficients. So I am not doing all that calculations. The purpose of this lecture is just to discuss how to select proper particular integral for given non-homogeneous equation. So whenever functions are in the addition or subtraction, we will write down the corresponding families, and for each family we will check whether any member is present in the complementary function or not. If any member of any family is present in the complementary function, then we will modify that particular family by multiplying with powers of x as required, and then we will consider union of corresponding families, and linear combination of members of this union will be the proper choice for particular solution. We consider some more problems. This is given differential equation y double dash plus 2y dash plus 4y equal to 2x square plus 3 into e raised to minus x. So I have written complementary function. You can solve it by solving the corresponding auxiliary equation. Lambda square plus 2 lambda plus 4 equal to 0. So I have written directly complementary function of this equation. Now there are two functions in the addition. The family corresponding to 2x square is 1x x square. Now no member of this family is present in the complementary function. Similarly, family corresponding to this function is e raised to minus x, and e raised to minus x only is not present in the complementary function. So we can consider union of these two families, 1x x square union e raised to minus x. So we have 1x x square e raised to minus x, and linear combination of this family, linear combination of members of this family will be our choice for particular integral. So a into 1 plus b into x, c into x square plus d into e raised to minus x. So we consider some more examples. Here given equation is y double dash plus 4y equal to x sin 2x. Corresponding homogeneous equation will be y double dash plus 4y equal to 0. So its auxiliary equation is lambda square plus 4 equal to 0. So if you solve this, you will have lambda equal to plus or minus 2y. So therefore complementary function is c1 e raised to 0x, that is 1 into cos 2x, plus c2 e raised to 0x into sin 2x. So this is the complementary function of given non-homogeneous equation. Now right hand side is rx equal to x into sin 2x. So here two functions are in the product. So first we have to write down the families corresponding to both the functions, and then we have to take their Cartesian product. So family corresponding to x is 1 comma x, family corresponding to sin 2x is sin 2x cos 2x. So I will not check whether any member of these two families is present in the complementary function or not. That I will check after taking Cartesian product. If two functions are in the addition or subtraction, we have to check for individual family. But if functions are in the product, first we have to take their Cartesian product of corresponding families, and then we have to check whether any member of that Cartesian product is present in the complementary function or not. So first we consider 1 into sin 2x, that is sin 2x, 1 into cos 2x. Then we consider x into sin 2x and x into cos 2x. So this is the Cartesian product of the family of derivatives corresponding to these two functions in the product. So now we have to check whether any member of this family is present in the complementary function or not. So we can observe that sin 2x is present in the Cartesian product as well as in the complementary function. Similarly, cos 2x is also present in the complementary function. So we have to modify this family by multiplying with x. So we multiply each member of this family by x and we obtain modified family, x square sin 2x, x square cos 2x. Now again we check whether any member of this modified family is present in the complementary function or not. So in complementary functions we have cos 2x and sin 2x, and there is no match with those two functions, or no member of this family matches with the members in the complementary function, or no member of this family is present in the complementary function. So this is the proper family for choice of particular integral. So try to understand the difference. Here two functions are in the product. So first we consider Cartesian product of corresponding families, and we check whether any member of Cartesian product is present in the complementary function or not. We are not checking for individual family of derivatives. Okay, we will check match with complementary function after taking Cartesian product. So that is the difference between addition and multiplication. If two functions are in the addition, then we will check corresponding families of both the functions. We will write down the family corresponding to this function, and we will check whether any member is present in the complementary function or not. If it is present, then we will modify that corresponding family only. But if two functions are in the product, first we will take the Cartesian product of families corresponding to functions in the product, and then we will check whether any member of the Cartesian product is present in the complementary function or not. So now this is our modified family, and our particular integral will be in this form: a into x sin 2x plus b into x cos 2x plus c into x square sin 2x plus d into x square cos 2x. So after this we have to substitute value of yp and yp double dash in given equation, and then after simplifying and comparing the coefficients, we can find out these undetermined coefficients. So I am not doing that calculation parts. We have done enough examples to explain this type of things. We move towards the next problem. Y double dash plus 4y equal to x plus sin 2x. So this is the problem in which left hand side is same as this equation and right hand side is addition of these two functions. Instead of x into sin 2x, we have x plus sin 2x. So we know that complementary function for this equation is c1 cos 2x plus c2 sin 2x, as we have done in previous problem. Now here two functions are in the addition, so I will write down the families corresponding to each function, and then I will check for each family whether any member is present in the complementary function or not. So the family corresponding to function x is 1x, and no member of this family is present in the complementary function, so we keep this as it is. Now the family corresponding to sin 2x is sin 2x comma cos 2x, and we check whether this any member of this family is present in the complementary function. So we find that both the members are present in the complementary function, so we modify this particular family. So here we have x sin 2x, x cos 2x. Now we check whether there is any match with the complementary function. So here we have x sin 2x, x cos 2x, and here we have cos 2x sin 2x. So there is no match with the complementary function. So this is our modified family for sin 2x. So try to understand the difference. In previous problem, two functions are in the product. So first we write down the families corresponding to each function in the product, and we take their Cartesian product, and after taking Cartesian product we check whether any member is present in the complementary function or not. So whenever two functions are in the product, First we will take Cartesian product of family of derivatives corresponding to each function in the product, and then we will check whether any member of the Cartesian product is present in the complementary function. But if functions are in addition or subtraction, we will check for each family. First we will write down the family corresponding to each function, and we will check for individual family that whether any member is present in the complementary function or not. And if there is any member present in the complementary function, we will modify that particular family only. Okay, fine. So now this is the family corresponding to function x, and the family corresponding to sin 2x is this modified family. And because two functions are in the addition, we are considering union of these two families. So union is 1x x sin 2x x cos 2x, and our proper choice for particular integral is linear combination of elements of this family. So it is a plus b into x, c into x into sin 2x plus d into x into cos 2x. Okay, fine. So we consider next problem. Y double dash minus y equal to e raised to x x into sin 2x. Now here we have to first write down the complementary function. Auxiliary equation corresponding to this homogeneous equation is lambda square minus 1 equal to 0. So this will give me lambda equal to 1 and minus 1, real and distinct roots. Therefore complementary function is c1 e raised to x plus c2 e raised to minus x. Now here there are three functions in the product. So we have right hand side equal to e raised to x x into sin 2x, and because these three functions are in the product, we write down the corresponding families and we take first their Cartesian product. Family corresponding to e raised to x is e raised to x, family corresponding to x is 1x, family corresponding to sin 2x is sin 2x cos 2x. So because functions are in the product, we take Cartesian product of family of derivatives corresponding to each function. So first we take Cartesian product of these two sets. So e raised to x into 1 and e raised to x into x, or x into e raised to x. Then we take Cartesian product of these two, sin 2x cos 2x. So this is equal to, now first we fix e raised to x. So e raised to x into sin 2x, e raised to x into cos 2x. Now we fix x into e raised to x. So x e raised to x sin 2x, x e raised to x cos 2x. So this is the Cartesian product. Now we check whether any member of Cartesian product is present in the complementary function or not. So in complementary function we have e raised to x and e raised to minus x. So that does not match with any member of this family. So therefore our choice for particular integral is linear combination of elements of this family. So a into e raised to x sin 2x plus b into e raised to x cos 2x, cx e raised to x into sin 2x plus dx e raised to x into cos 2x. Okay, then you can substitute value of yp in this equation and try to solve the corresponding equation and try to find out the values of these undetermined coefficients. Next problem is y double dash minus y equal to e raised to x plus 3x plus 5 sin 2x. So here left hand side is similar to this equation 5. So complementary function will be same as in problem 5. So here we write directly complementary function is c1 e raised to x plus c2 e raised to minus x. Now here functions are in the addition. So we will find out family of derivatives corresponding to each function, and we will check whether there is any match with the complementary function or not. So this is the family of derivatives corresponding to e raised to x, and e raised to x is present in the complementary function. So we modify this family by multiplying with x. So we have x into e raised to x. Now this is not present in the complementary function. So this is the proper modified family corresponding to e raised to x. Now corresponding to this function 3x, the family of derivative is 1x, and corresponding to 5 sin 2x, the family of derivative is sin 2x cos 2x. We have to check for individual family. So there is no member of this family present in the complementary function. Similarly, no member of this family matches with any member in the complementary function. So now we have to consider union of these three families, x e raised to x, 1x and sin 2x cos 2x. So that will be the required family for the choice of particular integral. 1x union, here we consider sin 2x cos 2x. So we know how to write down the union of three sets. So we write all the members present in 1, 2 or 3 sets, or in all the sets. So our choice for particular integral becomes a into x into e raised to x plus b into 1 c into x plus d sin 2x plus e cos 2x. So in this way we can select proper particular integral for method of undetermined coefficients. So proper choice of particular integral is necessary to find out the correct particular solution. So this is all about method of undetermined coefficients. We just recall that this method is applicable for special right hand sides, exponential function, polynomial function and trigonometric functions, sine or cosine, and linear combination of all these functions and product is allowed, or product, sum or difference of all these functions is allowed for finding particular integral using method of undetermined coefficients. So it is applicable to special right hand sides only. So what if right hand side is different from these functions? Suppose right hand side is say 10x, then we cannot apply method of undetermined coefficients. So for that we have to think for another method. So we have another general method for finding particular integral that we are going to discuss from next lecture. So I hope you like this lecture. Thank you very much.